both sides can agree, you have to write a thing that's like the rules in the middle and say, okay, everybody, as long as we all do this, we'll be fine. It's as simple as picking on which side of the road the cars can drive on. It works fine no matter which side, but if each car randomly picked, it would be really kind of a mess. So if you look at the typical URL, and this is one of the things that the web innovators in 1980 really invented that was wonderful, and it seems second nature today, but in 1990 it was rather revolutionary in that these uniform resource locators included in themselves a protocol, the host to connect to, and the document to retrieve. So this is one of the clever ideas that the web came up with, because we used to have to pick a program like FTP or Telnet or whatever, SMTP, then we had to go to the right host, and then we had to talk to that host a certain way. So in HTTP, it's a really simple protocol invented in 1989 and 1990 by Tim Berners-Lee and Robert Cailliau at at CERN. And they created a protocol that we have grown to know and love and use for way more than retrieving documents, as we'll see in the upcoming chapters. So we're going to talk a little bit about what happens when you click on a page that has a link. Now, there's all kind of fancy stuff that can go on, but this is the basics. And so let's just imagine for the moment you are sitting looking at a web page, drchuck.com/page1, and inside that there is a hyperlink. It is a indication that says when you clicked on this page, go to a different page. And in that you see the name of the page that you're supposed to go to. So we click on this link, and that is a browser. This is an application. This is a process or an app that's running on your computer. This is the browser, okay? And when the browser sees the click inside your computer, then the browser makes a connection to port 80 on the web server, drchuck.com, and sends the request. This request that it sends is precisely specified by a standard, which we will see in a second. Then the web server does some magic work. Oops, let's go back. Then the web server does some magic work in here, reads some files, runs some code, does whatever, constructs an answer to our phone call, and sends it back. And it sends, in this case, back a web page in the format of HTML, the hypertext markup language, which is different than HTTP, which is the protocol that we're exchanging. HTML is the format of the document we're getting back. And in this has an anchor tag, href, and the end of anchor tag, and some highlighted text. And now your browser gets this back and then renders it according to the rules of HTML and CSS and JavaScript, etc., parses it, and then makes a pretty web page. And this web page happens to have a link back to the first page, and if you click there, it will do this over and over and over again. And that is the request response cycle. And that's governed by a series of internet standards. These are standards that were built from the 60s, 70s, 80s, and 90s and continue to this day by a group called the Internet Engineering Task Force, or IETF. The documents they produce are called RFCs, which stands for Request for Comments. The word RFC is kind of like a sort of joke, as it were. They're trying to be kind of funny in that. Funny is not the right word. It's ironic in that they're trying to say, even some of the protocols of the internet that we've used for several decades, they're always interested in improvements, and that's what the RFC stands for, and they're all named RFC-whatever. And if we were going to cruise around, we could find some various RFCs, and this is RFC 2616. It might have been revised since then, but this is like a document, and this is what they look like. Hypertext Transfer Protocol version 1. And so you're reading this document, you're going to write a browser, and you want to talk to the application protocol that is HTTP. This is one of many documents that helps define what HTTP is. So if you look down and said, oh, here's what a request looks like. This is how I'm going to get a document from the server. And you keep reading and you keep reading, and it says you're supposed to have the request method with a space, with the request URI, the request method with a space, with a URI with a space, the HTTP version, and the carriage return to line feed. That's what it's saying. And so it looks kind of like this, right? We say get the document followed by a space. There's got to be one space. You do two spaces, and it's going to be quite frustrating, okay? And so this is an example that you can run on a number of on Linux operating systems and Macintosh operating systems with no changes, if you install Telnet on your Windows box, you should be able to run something like this as well. So Telnet is a program that we used in the old days. It used to be how we logged into servers, but because it doesn't encrypt your data back and forth, we don't use it anymore. But it basically is a program that can open a socket to a host on a port. And I'm saying Telnet to this host on port 80. And at this point, I am connected, and whatever I type on my keyboard is going to be sent to that server. Now, if you're doing this, you probably want to cut and paste this really fast, because if you take too long, most web servers will be like, you're a human. I don't want to talk to humans. I want to talk to programs. So remember to type this fast enough, and then you have to hit Enter twice. So you have to have a blank line here. Just type this exactly as it's shown, and then you will get back the server. If you do it right, the server, and the server is properly configured, the server will give you back some headers. And this is metadata about the document you're going to get. For example, it's saying it's got text/HTML, which means that the remaining stuff is going to be in HTML, hypertext markup language. It has a blank line, and then the actual document, and then the connection is closed. And so if you do this, you can set this up in a way that you can run this on your own computer and in effect hack through the back door a web server. Now, you can't hack the secure web servers, and mail servers used to be easy to hack, but they're harder to hack now because they challenge you for information. But part of the reason I'm so obsessed with the command line is this is how real hackers work, and they know how to talk some of these protocols more directly. And so we think of this beautiful, sophisticated application talking to some other thing, and it's all pretty, and we got wonderful clicky buttons and nice usability. But the reality is, like in the Matrix Reloaded here, the kinds of things that really talented hackers are doing use command lines, and they really know what's going on, and that's how they do it. They understand what's going on better than the developers of the computers that are trying to be resistant to the hacking. So I come from a long line of using the command line, and that's why I encourage you to use the command line in this course. So the next thing we're going to do is we're going to go up into the application layer, and instead of typing those commands by hand, we're going to actually send them from Python and write a very simple Python web browser. In this section, we're going to write a web browser using Python. So we've already got a socket. We know how to write a socket. In the previous section, we played with the protocol and used Telnet to do it by hand, and now we're going to do it in Python. And what you're going to find is it's not that hard. So here we go. So the first 3 lines of this program: import socket, make the socket. Remember, the socket isn't really got the connection. So when you make the socket, again, we're going to make a stream-based socket, and it's suitable for going across the internet. The connection, it's like ring, phone call, connect to data.pr4e.org and port 80. And so that basically says extend the socket across and connect to a web server. And so there's got to be a piece of software running, and this will blow up if the software is not running. Okay? So then, now we've got a phone. We've made a phone call. Now, whether or not the remote side says hello or not is up to the application protocol. And in this case, the web servers say nothing, and they wait for you to talk first. So we're the web browser in this case, and so we're going to talk first. And we know what, because we read the documentation, we know that we're going to send get blah, 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 space, blah, 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 ht1, and then 2 new lines. Return, return. Remember, we had to have a blank line. We'll talk a little bit about this encode. It's preparing the data to go across the internet. And then we say send it. And so this basically takes that little string and sends it across the network. And then this piece of software is waiting for it. And then the software goes and reads a file or does some other stuff, and then it starts sending us data back, which we can then choose to receive. So now I write a real simple loop. We're going to receive these things 512 characters at a time. So we're going to loop through, receiving 512 each time. And if we get 0 characters, that means it's end of the stream. The stream is closed. And if you look at the little example from the previous one, you saw connection closed. When the connection is closed, we get an indication that it is because we ask for some data and we get 0 data. Otherwise, if there might be more data, this will wait. If the network is slow, you'll see, if you do a print statement in here, you will see that this will pause from time to time on a really slow network. If your network is fast, it'll just go blank and it'll be so fast it won't matter. But this is how we go. So this is basically until the entire socket until the socket is closed. We're going to read this data.